Good afternoon, everyone, and welcome to our session today. My name's Jeff Innes. I'm a Bing Maps technical specialist with Microsoft, and I'm going to be speaking with you today about building engaging Windows Store apps with Bing. And we're going to be focusing on the tools that are available in the Bing Developer Center today, with a special focus on the resources that can accelerate your development with those tools. So with that, let's take a look at our agenda. So I'm going to spend the first part of the session giving an introduction to the APIs that are available within the Developer Center. Then we're going to take a look at 4 specific integration scenarios that combine 2 or more of these APIs into an application. And those will actually be Visual Studio solutions that you'll be able to download from the code gallery on MSDN. And we're going to dive into the code for a couple of those solutions, review those, and then do some live demos as well. We're also going to be taking a look at some of the core APIs for Windows Store app development and looking at the top code resources that we've got available to enable you as developers to accomplish specific tasks with each of these tools. We're also going to be taking a look at a few fairly newly released features for some of the tools we're talking about. Let's proceed here. I know we've got a lot of content, so I'm going to charge right in. So Microsoft has been making major investments in the underlying technology that underpins Bing.com, and also making services available to other devices and applications such as Windows, Windows Phone, Xbox One, Office, and more. And this session is really about how you as developers can take advantage of those investments that Microsoft's been making and build out engaging and intuitive experiences for your Windows Store apps. So I'm actually going to switch over to my laptop here for a moment and look at the Bing Developer Center quickly. Because while we've been here at Build, there have actually been some new things released to the Developer Center, so I want to call those out first off. So one of the new things that was actually presented during a session at Build is app linking. This is basically something that's available to you now to increase the discoverability of your Windows Store and Windows Phone apps. And you can basically link your app to Bing-powered search results on Windows and Windows Phone. And the session in question was 2-655. So if you want to take a bit of a deep dive in that area, then check out that session when it's published on Channel 9. Another thing that's just recently been released is the Knowledge widget. And this is something that is targeted at webmasters, and it's a JavaScript-based widget that you can incorporate into your websites and web pages, and it will analyze the content of those pages and identify entities and then visualize information about those entities in the actual page, powered by the Bing Knowledge repository. And we've also got some developer information about how to mark up emails so that Cortana can take advantage of them via contextual awareness. So those are some of the things that have been released and discussed in other sessions within the Build conference. And before we dive into the APIs that we're going to be talking about in our demos, I'll just touch on a few of the other tools that we've got available as well, so you're aware of them. The Webmaster API, it allows programmatic access to things such as URL rankings, crawl statistics, and more, other data that webmasters would otherwise have to log into the Webmaster Tools portal to get. The Ads SDK allows you to incorporate ads into your Windows Store apps so you can monetize those apps, whether they be JavaScript-based or XAML-based Windows Store apps. The Ads API, on the other hand, it allows programmatic management of campaigns for advertisers and agencies so they can manage those campaigns over the Yahoo Bing network and be able to draw reports on them over time and optimize those advertising campaigns. And then also, we've got the App Producer, which is a tool that makes it super easy for news publishers to get a branded app into the Windows Store. So we're not going to be focusing on those in much detail in our presentation now. We're going to be focusing on these top 5 here: maps, speech, translator, search, and synonyms. Before we get into the features of these, I wanted to give some insight into the availability of these tools for Windows Store apps, both JavaScript and XAML, as well as Windows Phone. And also, certain tools are available via web service, so you can incorporate them into other platforms as well. So you can see we've got a pretty broad capabilities across the platforms that we've got listed there. You'll notice that a couple of the tools, search and synonyms, those are made available via web services. So we can, of course, incorporate them into our Windows Store and Windows Phone apps, but we don't have a dedicated control for them in the same way that we do for some of the other tools and platforms. Another thing I wanted to mention about the actual presentation in the deck is that we're going to be going over a lot of resources, and you'll find developer tools either in the actual slides, links in the actual slides, or in the notes of the slides, which will be included when it's published and made available on Channel 9 as well. This particular slide incorporates getting started information for each tool and platform. So for example, if you wanted to get started using maps in a Windows Store app using JavaScript, you'll find some getting started resources if you download the deck. Same for the other combinations as well. And one other thing about how you actually get access to these tools, with the exception of maps, the other 4 are all accessed through the Windows Azure Marketplace. So you sign in there, you subscribe to the service, and you can get your credentials through the Windows Azure Marketplace. Maps is a little bit different. It's got its own dedicated portal called the Bing Maps Account Center. You can go there, sign up for an account, and get your Bing Maps key, which you'll use in your code to authenticate your platform usage. And I'll also make mention of another session that took place at Build. It was dedicated to Translator. It was session 2-656. If you want to check that out on Channel 9, they actually went through step by step the process of going to the Azure Marketplace, subscribing to the translator service, installing the translator control, grabbing your credentials, and getting started. So if you want to get a feel for that process, they've gone through that step by step in that session, so you can check that out. And so before we get into some of the other APIs, I wanted to just briefly touch on synonyms, because synonyms is pretty simplistic in terms of its usage. It's made available via a RESTful OData web service, and you can pass in query terms. These will typically be things such as location names, people's names, product names, and other entities. And it will give you back one or more alternate names or synonyms for the term that you've passed in. So an example of that might be if you passed in SeaTac, then you might get back Seattle-Tacoma International Airport as a synonym there. And it's useful for augmenting your search-based applications. So let's say, for example, you've got an app and you're trying to sell products to your app users. You might want to augment your search capabilities with aliases that you draw on from synonyms so that they've got a maximum chance of being able to find the products that you're selling. So that's how you'd use synonyms. With that, let's start have a brief overview of some of the other APIs that we're going to be taking a look at in the actual code reviews and demos. So perhaps the broadest of the tools we're going to be looking at is Bing Maps. So Bing Maps offers controls for both Windows Store JavaScript and XAML-based applications. And these controls provide the interactive mapping capabilities and navigability that surface the base roadmaps and the rich imagery that you'll see within the platform. The imagery includes such things as bird's eye imagery, oblique imagery, such as you see in the screenshot here, and also venue maps. That's an interesting feature that many developers are not aware of. Microsoft has venue maps, which are basically interior maps, maps of interior spaces for about 5,000 venues around the world. International, probably about 60 or so countries that we have venue maps in. And these would be things such as malls, stadiums, airport terminals, and more. So you can bring those interior maps into your actual application via venue maps. We've got some location-based services that we're going to be taking a look at in our demos. They allow you to do things such as geocode an address. So taking an address, turning it into a latitude and a longitude so you can actually present it on the map. Reverse geocoding, which is the inverse of that. Directions, and these are available via RESTful services and a SOAP endpoint as well. You can also get access to geospatial data such as points of interest, traffic overlays that show current traffic flow, and also elevation data, so you can pass in points, lines, or bounding boxes and get back elevation profile information for your area of interest. One other component I wanted to touch on is that with the Bing Maps platform, you do also have the ability to create your own data sources, custom data sources in the cloud within Bing Maps. So if you've got location data that you want to be presenting in your application, you can define your own data source schema, upload your location data, and you've got accessible to you a query API that you can use to do spatial queries on your data, filtered queries on your data, and overlay it within Bing Maps. And I'm going to be touching on some of the advanced features that we've released fairly recently for spatial data services and data source hosting. And as a developer, you, of course, get access to the ability to overlay your data in meaningful ways, which is kind of fundamental from a developer's perspective. So that's a bit about Bing Maps. Let's touch on Bing Speech, which we're also going to feature in our demos as well. So I've got a little bit of information here about speech capabilities for both Windows Store apps and Windows Phone. We're focusing primarily on Windows Store apps here. And so we'll start there. The top half of the slide relates to Windows Store apps. And we have a speech recognition control available to us. This allows us to basically capture the user's voice and then transcribe that into text. And the Windows Store control supports 6 languages, and I'm going to be showing those languages to you in one of the demos. We've also got the ability to do speech synthesis through the speech synthesis namespace. And with Windows Store apps, you've got 12 languages that can potentially be available to you. Some of them have male and female voices, and there's also support for both plain text, so you can just pass in strings of text and have that synthesized into speech, or alternately, support for speech synthesis markup language, which allows you to control things such as the pronunciation of words, rate, and pitch. Windows Phone opens up a little bit more in terms of capabilities with a few more languages supported, and then the ability to launch apps or deep link into apps via voice commands as well. We're also going to be taking a look at Translator in a few of our demos. Translator is fairly broad as well, and I mentioned the fact that there was a session that was dedicated to Translator. So if you've got a keen interest in that, I'd recommend you checking the video of that out. So there's quite a broad array of capabilities there, and a subset of those are made available via a control for Windows Store apps. And this control has 2 primary functions. Firstly, it allows you to translate text from one language into another. You can either specify the input language or have it auto-detected. And you can also determine programmatically what languages are actually supported. And there's probably about 40 or so languages that we've got support for via Translator today. Through the other endpoints that are available, there are some additional services and features outside of the Windows Store control. You can do additional things such as returning audio in either WAV or MP3 format for the translated text, translating arrays of text into other languages, and also being able to map words from your input phrase into the corresponding words in the output phrase, and things such as that. There's also a widget to allow you to do wholesale translation of web pages as well. So we're going to be taking a look at that in a little bit more detail in our demos. The final one I wanted to touch on was the Bing Search API. And this basically is another RESTful OData web service that you can use to pass in query terms and get back results as indexed by Bing. And the source types you can work with here are images, video, web results, news items, and also related searches and spelling suggestions. Related searches would be things such as if you pass in a query term of San Francisco, you might get back some related searches such as San Francisco weather, San Francisco hotels, etc. And then spelling suggestions are additional alternate spellings if there's a misspelling on the query that you can present back to the user of your application. And we've got the ability to add in additional search inputs beyond just the query to kind of localize by market and also filter on, depending on the source type we're after. We can do things such as filter for small-sized images that have a square aspect and things like that. So with that, let's start taking a look at some of the applications, and we're going to take a look at some code, and we're going to do some demos now. So the first application that integrates multiple components that we've been talking about is our speech-powered maps demo. So this is an application that's available for you. We've got a full code walkthrough as well as Visual Studio solution download, and this allows you to basically combine speech recognition, speech synthesis, Bing Maps, and the geolocation API into an application that allows you to basically speak a place name and have the map dynamically navigate to that place, or alternately request directions via voice. We're also going to be feeding back information to the end user as they interact with the map and the directions. So it's a kind of a two-way speech-powered mapping experience. So we're going to take a look at, we're going to first take a look at the code, and then we're going to do a demo of the application. Okay, so I've got the sample application that you're able to get access to here in Visual Studio. And the first thing I wanted to call out is that we're using a couple of the controls. Firstly, we're using the Bing Maps control, and we're using the Bing Speech Recognition control. So those need to be downloaded from the Visual Studio gallery and installed, and you also need to add references within your project to those two. And so we've done that. We've also added a reference to the Microsoft Visual C++ 2013 runtime package. That's a requirement for Bing Maps as well. And we've obtained our credentials from the Bing Maps Account Center and from the Azure Marketplace. The other thing that we need to do is in our app manifest here, we need to enable device capabilities for both location and microphone. We're going to use the location to identify the user where they're located and use that as a start point for our route. And we're also going to use the microphone capabilities because we need that to be able to capture the user's speech and power the application. So our XAML code, I wanted to just take a quick look at some of the key components there. It's fairly basic. It's a map-based UI with a panel to present our results and an app bar along the bottom that the user is going to use for interaction. The first thing I'll note is that we're embedding our map control here. This is what will present the actual map UI, and we add our credentials. This is our Bing Maps key that we obtained from the Bing Maps Account Center. That's how we authenticate our usage. The other thing that we've got here is our media element. We add this so that when we synthesize speech, we're basically creating speech synthesis streams using the speech synthesis namespace, and then we're going to actually play them to the user with this media element. And the other component I wanted to call out was the UI component of the speech recognition control. So this is what the user will see. It will communicate information to the user about the state and the state changes as we're capturing their voice. So we'll take a look at the code behind here and have a little bit of a journey through what happens as the user is speaking place names and obtaining driving directions. So with our page-loaded event handler here, we're doing a few things. Firstly, you can see that we're instantiating our geolocators so that we can identify their location according to the geolocation API that we'll use for our starting point for our route. And we're configuring our credentials, instantiating our speech recognizer, and then associating that with the actual UI element that's going to convey information about our speech capture to the user here. So we do have the ability to capture speech in 6 different languages. In this instance, I'm basically going to be passing in English because I'm going to be speaking English for the purposes of this demo. And when we've got our client ID and client secret that we're passing in as our credentials, these were obtained from the Azure Marketplace when we registered our application. So what the user is going to do is they're going to click a microphone button in our app bar to initiate the interaction. So we're going to use this method here, the Recognize Speech to Text Async method of our speech recognizer. This will manage the actual capture of the audio and the transcribing of that into text so that we can use it. We're able to get access, in the result there, we're able to get access to the confidence of the result, and we've got about 4 different confidences we can work with. In our application, we're basically just looking to make sure that we've got a semi-reasonable level of confidence before proceeding, and if we do, then we're going to analyze the text that we've captured. We're going to be looking for one thing in the text initially, and that'll decide which direction we're going to go, whether it's basically navigating the map or obtaining directions. So we're actually going to analyze the text that we've captured. If the user said directions to, then we're going to basically attempt to obtain directions to the destination that they've spoken. If they didn't say that as the first part of their speech, then we're simply going to use our geocode method to engage the Bing Maps geocoder and navigate the map to a new location. One other thing I'd mention is that we have the ability to configure tips. These are things that will be surfaced through the Speech Recognizer UI. So if you have particular information you want to convey about how best to use your application, then you can configure your own tips. These, and I've got a couple in here that's such as say a place name to navigate the map to that location, or to obtain driving directions, say directions to, and then a place name. So we're guiding the user in terms of how to use our application here. So let's say we've captured an instance where the user has just simply stated a place name. We're now going to use Bing Maps to geocode that and show it on our map. So we've got our geocode method, and it's taking a query, a string parameter here, which is the query, the place name that they want to navigate the map to. So within Bing Maps, we've got access to a search API, and this search API allows us to do the geocoding and the reverse geocoding. We're going to be focusing on the geocoding side of it, and that's basically taking a place name and then turning it into accurate latitudes and longitudes. So what we're doing is we're configuring our geocode request options, and in essence, they're just simply the actual place name that the user has spoken. We're going to use our search manager and the geocode async method there to basically make a call out to the Bing Maps platform and get back location results, which will include one or more locations, and each one will have a name and a latitude and a longitude, as well as some other metadata that we can use to navigate the map. When we get that back there, we're going to go through the data that we get back in our response, and we're going to, for each location that comes back, add a push pin to the map. So we're constructing our push pin. You'll see that with each push pin we add, we're adding the name, the place name of that result as the tag property of our push pin. And that comes into play later because we're also adding a tapped event handler to our pin so that we can actually say the place name back to the user as they interact with the map and tap on the push pins that we add. We then use the location that came back from the geocoder to position our push pin and then add it to the map. We're also going to set the map view to the location of the first result that came back, and that effectively navigates the map to that location. For the directions method, what we're going to do is, it's very similar. We're basically passing in the destination name that they stated, and we're going to obtain driving directions. And when we do that, one of the first things that we do is we use our geolocator to get the user's location, and that'll be the starting point for our route. And then we're adding the destination using the place name that was spoken. So we've got a directions manager class that will allow us to manage the retrieval of routes and then present them on the map. And we're able to configure a collection of waypoints. So these are stops along the route. For our route, it's basically just 2 waypoints, the start and the end. So we're adding our 2 waypoints. You can see one is done with lat longs, and the other is done with the destination name. So we've got that flexibility to add waypoints using both of those methods. So we actually use the calculate directions async method to make an asynchronous request to obtain those driving directions. And then when we do, we're going to analyze our response, make sure that we're going to use the first route that's returned. If there are multiple routes returned in the response there, we're going to display the route path to the user. We're going to add a couple of push pins for the start and the end points of the route. And the other thing that we're going to do is we're going to data bind our route to a stack panel so that we can present the actual step-by-step instructions on the side and have some interactivity with that as well. And throughout this, when the user is doing certain actions, such as clicking on specific driving directions, we're also using speech synthesis to communicate back to the user. We're using this speak method here. For example, we're going to inform them what the drive time to their destination is and what individual step-by-step instructions are. So taking a look at the speak method just briefly, we're using the speech synthesizer here. We're instantiating that and then using it to create a speech synthesis stream here, just using the text. This is plain text that we're passing to the method so that we can obtain our speech synthesis stream. We subsequently pass that to the media element that I mentioned earlier, and that's how we actually have that spoken to the user. So that's a kind of a walk through the application here. I'm going to attempt to actually run this application, and we'll see it in action. Okay, so I'm going to put on my headset for optimum audio capture of my voice here. So you can see we've got our navigable map, and I've got our app bar where I'm able to actually start speaking to the application. So I'm going to try to navigate to a few place names here. Boston, Massachusetts. Okay, so easy to navigate there. I'm going to try a kind of a landmark now. The Eiffel Tower. Okay.
Error encountered processing speech.
Okay, I'll try that again. The Eiffel Tower. Okay. All right, so I'll try clicking on our place name
Boston,
here.
Ma.
And let's clear the map. I'm going to try, just give one more try here. Directions to Athens, Georgia.
Getting directions, driving time to destination is 75 minutes.
Okay, not sure why we weren't able to capture the other things I was saying there, but you can see I've now stated I wanted to get directions to Athens, Georgia. This is now capturing my speech, capturing the fact that I said directions to, and then presenting us with our route. And this is a kind of a two-way communication, so I can pick some specific instructions here. I'll tap on that.
Take ramp and follow signs for I-75 north/I-85 north.
So we can easily navigate the map from place to place and have the speech synthesis stating that place name back to us, or stating that instruction back to us. Okay, let's go to our, you'll notice
At
that
exit 8, take ramp right for GA10/US78 east toward Lexington RD.
based on the our kind of network configuration for the build conference, you'll notice that the geolocation API picked me up in a different kind of destination. You'll find that if you're connected to some of the networks here, that you'll get the same thing here. I'll try one more time to see if we can get one of the ambiguous results here. I'll clear that. San Francisco. Okay.
Error encountered processing speech. Error encountered processing speech.
San Francisco. Okay, so this is an example where we've got an ambiguous result. So we've got multiple San Franciscos around the world. We're going to return the most prominent one first, but we've got other San Franciscos as well.
San Francisco, Venezuela.
That we can present to the user and navigate the map as well.
San Francisco, Argentina.
Okay, so you can see we've got that kind of two-way speech where we're communicating to the application with voice and the application is communicating back to us with voice as well. And so we can create a kind of an intuitive way to interact with the map. And you can find in many instances that just simply being able to speak place names or directions destinations can be a lot quicker than just simply typing them in, even if you've got a full keyboard at your disposal. Okay, so with that, let's take a look at our next. Let's take a look at our next example. This is another one that uses voice, so hopefully our voice capture will come through clearly here. This one integrates Bing speech recognition with Bing speech synthesis and the translator to basically allow us to speak a phrase in one language and then have that phrase spoken back to us in another language. And one of the interesting things about this application is that it includes code to manage the intersection of the languages supported by translator and the language or the voices that you can speak with speech synthesis. So there are probably 40 languages or so that are available to be used with translator, and 12 you can potentially use with synthesis. And so that it manages the overlap and includes the ability to present all the voices that you can use for that particular application. Okay, so let's give this one a crack here. Alrighty, so this is our simple UI. This is again another example that you're able to download and use, and the full code is available for a Visual Studio solution for you. So the first thing that you'll notice is that we've got our input language here. This, I've actually hard-coded this with the languages that are supported for speech recognition. And we've got 6 of them there, but the output, we're able to actually programmatically determine which ones we should present here. And this is the intersection of those that are supported by translator and those that I've actually got available to me with the speech synthesis namespace. So we've got, it's important to note that you need to actually have installed a language and downloaded the language pack in order for this to work here. So I've done that for a few of the different languages. We've got Spanish, French, and some Chinese there as well. So we're going to attempt to do some speech capture and translation on the fly. I hope you're enjoying the conference.
J'espère que vous vous plaisez dans la conférence.
Okay, good stuff. So I'm going to try something that's a little bit ambiguous there. That just basically simply takes the first result and presents it to us. Let's try another one that's in Spanish here. Okay. Where is the hotel?
¿Dónde está el hotel?
Okay, let's try it the other way around just for some fun here. Okay, I'm going to try some Spanish. ¿Dónde está la escuela?
Where is the school?
Okay, I'm going to mix it up here. Let's try some, up the ante a little bit. Okay. Ni hao ma.
How are you?
Okay, I'm feeling strong. I'm going to go for gold here. Okay. 我学习中文.
I get up for.
Okay, that's not what I was trying to say, unfortunately, but hey, what can you do? I obviously need to work on my pronunciation of Chinese. I can attest that the AV technician who was assisting me was up here. She's actually studied Chinese and was speaking some phrases, and she was nailing it time after time. So that's great. It's just my particular Chinese pronunciation leaves a lot to be desired. It's optimized for up to 2 sentences. That's the kind of ballpark that you'd be aiming for before you'd want to kind of start capturing or analyzing the audio and having it transcribed. There's a lot more you can get a lot more from the translator side of things, though. And I think about 10,000 characters can be translated on the fly programmatically with the translator API. Okay, so I'm not going to go into the code of this particular application, but I just wanted to give you some exposure to that. We've already seen the speech recognition in action, and we've got that here. So with that, I'm going to switch over to our PowerPoint. We'll just take a look at a couple of other examples. So the next one I wanted to touch on is one that's a map-driven search. This one integrates Bing Maps with the Search API, and we're going to be using the map as a kind of an intuitive UI, and we're going to be surfacing information from the Search API, news results, images, video, web results as well. And we're going to use the context of the map as it's being navigated to surface those results and influence those results. So this is another one that I want to take a look at the code for here. Okay, so this is our application, taking a look at it in Visual Studio again. We've got a very similar kind of map-based UI where we're surfacing results on the sidebar. And what I'm going to do is have a little bit of a walkthrough. And first thing I wanted to note is we've again got the Bing Maps map control installed, and it's added as a reference. And in this particular solution, this is again available for you to download, as are all the ones that we're reviewing here. This one includes some JSON data contracts so that we can interact with the two web services. They're both RESTful web services that we're going to be retrieving JSON data from. One is a data contract that we've configured for the Bing Maps location services. We're going to use that for reverse geocoding this time, passing in a latitude and a longitude, and then turning that into contextual information, which we're going to use to power our search. And the other JSON data contract that we're making use of is for the actual Search API itself. So we've got those configured, and they'll basically allow us to serialize those responses into basically objects that we can use within our code. So let's take a look at the actual, a little bit of the XAML code here. So we've got 4 different results that we're going to be aiming to get. Images, web, news, and video. So I've configured several data templates here, and those are optimized for the presentation of each of these kind of source types that we're going to be querying for. Again, we've got our map control added, but this time we've got a couple of event handlers that we've configured. One is going to capture the user's interaction with the map when they actually tap on a landmark. And these are landmarks on the map that are things such as restaurants, points of interest, tourist attractions, etc. So when someone taps on those, we're going to surface information from the Search API related to those. Similarly, if the user just double taps on the map at any time, we're going to analyze their map view and use that to return useful information as indexed by Bing that would be relevant to them. So let's quickly take a look at the code behind here. The Bing Search API is a little bit different from Translator and some of the others in that you just simply obtain a Bing search key. This is used to authenticate your requests to the web service, and you basically pass that in via as the username and the password for basic authentication when you're making your HTTP web requests. So we've configured that there. I've obtained mine from the Windows Azure Marketplace. So let's just walk through the journey in the code here when the user taps on a landmark. So we've got our, this is our event handler here, and we're receiving landmark tapped event args. This will contain information about the actual landmark on the map that they've tapped. So we can get access to the name, the category of the landmark, and the location of the landmark, so a lat long relating to that landmark. What we're going to do is we're going to use the Bing Maps reverse geocoding service. This is a RESTful web service that we can pass in a lat long and get back additional contextual information, string-based contextual information, which we can then pass to the Search API. And so we're passing in the location of the landmark, and we're also passing in an indicator of what kind of entity type that we want to get back from the reverse geocoding service. We're then combining the landmark name, the additional contextual information we get, and then any other terms that the user enters into a text box to pass that to our query so that we can surface results that are relevant to them. And then we basically combine those together, and we're going to use our search method here to actually issue the request to the Bing search service and then present the results. So let's take a look at the reverse geocode here. So in the other example that we were doing the code walkthrough for, we were actually using the search API that's available for the Bing Maps control, the XAML-based Bing Maps control. In this instance, we want to get access to a little bit more metadata about the reverse geocoding results. So I'm going to interface directly with the RESTful location service that's available for Bing Maps as well. And we're going to construct our, the URI for our request. We're passing in several parameters here. We're going to pass in our latitude, our longitude, and those will be basically the lat longs of the entity that was, or the landmark that was tapped. We've got our indicator of what kind of level of detail we want to get back, and then we're passing in our key here as well. So this is just a little bit of a kind of a housekeeping note, but when you're using the map control, you can actually extract the session credentials from the map session and use those in your subsequent requests to the RESTful service. And if you do that, it optimizes your usage of the platform because that request will then be considered like not contributing to your overall allotment of transactions that are used. So that's a useful thing to keep in mind. It is, possible to pass in the actual key itself, but from a kind of an optimization standpoint, it's best to obtain the session credentials and use those instead. Okay, so our getResponse method just basically issues the request, the HTTP web request, serializes the response, and allows us to get access to that data here. So I'm going to analyze the results, assuming we've got some results back from our reverse geocoding request. We do a little bit of kind of management of the result that comes back. If we do get a full address, then we parse out the address number before we send it to the search service. Otherwise, we just simply take the place name that was returned and use that. So an example here would be if we've got a landmark that was tapped and it was in a neighborhood of San Francisco, we might get back the neighborhood name that it was in, or actually the municipality of San Francisco, California. So that can be useful as a query term for the search service. So we've retrieved our reverse geocoding data, and now we're going to execute the search against the Bing Maps, or sorry, the Bing search service. And as before, we're basically going to construct our query request here, and we've got a few parameters that we're passing in as well. So we allow the user to choose which type they want what source type they want to get back in terms of results, using a list box in the bottom app bar, and then we pass in the value there for the sources that they want to get back. We've already constructed our query term, which should include the landmark and other contextual location information. We're passing in a latitude and a longitude, so this will further influence the results that we'll get back from a kind of a localization perspective. And then we're specifying we want the top 20 results in a JSON format so that our JSON data contract will be able to serialize the results there. And again, we issue that request and we get back the results. This getSearchResponse method will do that for us. So we're also going to be taking a look at what their intention was in terms of the results, and then, either we're going to be using the appropriate template for presentation of the data-bound results, and then choosing the appropriate result set and doing that data binding of our results to a list box. So that's a kind of a walkthrough of the actual application. So let's take a look at it in action here. So this is our simple UI. So let's say we're trying to use this in the context of a user who's just navigating around the map, wants to get information that might help them plan what they're going to be doing for the rest of their evening here. So we've got our fully interactive map here, and we know that we're going to be in the vicinity of the Embarcadero and maybe near Pier 3, so we're going to investigate what's around there. So I can see there's a few restaurants and bars that might interest me. I'm going to just tap on one of those, and we can choose our image results there. And so we can see a few images that look like they're showing the outside and the inside of this particular bar. I can get a feel for whether I like the look of that. Maybe I'll try this La Mar Cevicheria Peruano. I'm going to click on that one, and we can take a look at the results of that one. That one looks good. I might want to investigate that one a little bit further. Let's take a look at some news results here, see if we can find any reviews that might influence our decision here. So we find this looks like a review. I can read all about this particular restaurant, see if they gave it a good review, see if it looks good to me. Yeah, it looks good. Why don't I see if I can actually check out the website itself. So now I'm getting web results, and I can see this looks like the website for the actual establishment itself. So I can bring that up, check it out, and say, yeah, I like the look of that. I'm gonna make my booking here, and I'm gonna go dine there tonight. So you can see we've basically integrated our map surface as a great way to kind of explore, and we're surfacing additional information as indexed by Bing, using the tools that are available to us within Bing Maps to use location to influence those results there. Okay, so with that, I wanted to touch on another sample application. This is not one that we're going to do a demo of or review the code of, but I wanted to make you aware of it because you can take advantage of this and download it as well. This is an integration solution that combines Translator with Bing Maps. And what it does is it allows you to translate and localize your custom mapping content over top of the map. So Bing Maps does actually have substantial, powerful localization capabilities for the map and the services that Bing Maps provides. You can localize the map labels, you can localize the navigational controls, as well as the turn-by-turn directions that come back, and the search results. This shows you how you can use Translator to translate your own custom content that you're presenting on the map that Bing Maps is not, of course, able to localize. So you can take advantage of that. It'll give you insight into how to combine these two things for a localized mapping experience with your own data as well. Okay, so with that, we've taken a look at a couple of integration scenarios and reviewed a little bit of the code. I wanted to give you insight into some of the top code resources that are available for you to take advantage of to accelerate your development in terms of specific tasks with these APIs here. So first one we're going to take a look at is top maps code for XAML-based applications. And all of these are basically Visual Studio solutions that you can download and take advantage of. Draggable pushpins is the first one. You can basically enable your users to either place a pushpin or drag a pushpin on the map. This is great for solutions where you might want to have your user, let's say, reporting an incident or occurrence at a location. Let's say a 311 app for a municipality, for example. They can drag the pushpin, say, this is where the vandalism occurred or something like that, and then report it to you so that you can action it. Clustering of pushpins is a great resource. If you've got lots of data that you're going to be overlaying on the map, you don't want it to overwhelm the map view, so you can aggregate that data and present it using clusters. We've also got the ability to share maps via the charm. So if you've got a map view that your user is looking at in your application, you can use the share charm to actually embed a static map view, static image in the email that gets sent when it's shared out, as well as a link to the Bing Maps consumer site. There's another great one in here, augmented reality. This takes advantage of a CodePlex project called GART, G-A-R-T. It's an augmented reality framework. And this is a sample application that you can download, and it shows you how to overlay data from the Bing Maps platform, like points of interest, or your own custom data sources, both in a video preview and with an overhead view on Bing Maps, such as you see in that screenshot there. We've got some other data overlays for complex polygons, GPX data, such as you get from a GPS, so you can overlay traces, etc. So those are all available for you for XAML-based apps with maps. From a JavaScript perspective, we've got a solution you can download that shows you how to pull out points of interest from Bing Maps or your own cloud-hosted data sources within Bing Maps and create heat maps of them. So you can see we've got the screenshot here of heat maps. That's great for showing the concentration of your data. In this instance, it's showing hotspots, nightlife hotspots in the city. So if you wanted to give your users insight into where there are clusters of activity or where they might want to be going out for the evening, this can be an intuitive way to visualize that. We've also got another example that shows you how to tap into those 5,000 venue maps that I talked about. So as the user's navigating the map, you can be surfacing that to them and showing them where the venues that we have available are. There's also a geodata API integration. So Bing Maps can surface boundary data such as zip codes, municipalities, and other polygons. So if you want to create a thematic mapping experience, you can tap into those via the geodata API, and that shows you how to do that in that example there. From a speech perspective, we already showed an example of how you can combine speech plus maps in a XAML kind of a context, but we've also got one that's focused on speech plus maps in a JavaScript-based solution, and that one also shows you how you can do things such as query your data spatially with speech. We've also got an example that shows you how to customize that UI that you see in the bottom screenshot there. So if you wanted to create your own UI based on the state changes as the audio capture is taking place, then you can do that. That shows you how to do that there. And then there's also an example that shows you how to just basically launch a web search using your voice. From a search code perspective, we've already touched on the map-driven search example, but we've got a few other resources that are available to you to show you how to work with the various different source types from C# and VB, and how to get up and running as quickly as possible. And from a translator perspective, I did mention there was a translator session. If you've got a keen interest in translator, I definitely recommend you check that one out as a follow-up. But here are a few other resources as well. We covered the voice translator sample and the localizing of map data using translator. There is also a great application walkthrough for the tweet translator. And this basically shows you how to use the Twitter search API to pull in tweets based on a particular search term. It will analyze those tweets, and those that are not in English, it will translate them and then present them to you in a grid view here. I also wanted to point out a great resource that's available for those of you who want to take a deep dive into integrating mapping and location intelligence into your Windows Store apps. This is available for a free download. This was created by, or authored by a colleague of mine. His name is Ricky Brundrit. He's a Bing Maps technical specialist out of the UK. And this gives a really thorough review of the tools that are available to incorporate location intelligence into apps, the sensors, the SDKs that we've been reviewing today, consumption of services, integrating of spatial data, and also goes into several applications, including application walkthroughs for common scenarios for location intelligence in Windows Store apps. And one of the great things about this is that he has also published a code library on CodePlex that is super powerful in terms of augmenting your capabilities from a geospatial perspective. So you can get this. It's available now on CodePlex. It allows you to do things such as importing spatial data, and you can tap into data such as well-known text and well-known binary, the type of data that you'll be pulling in if you're working with SQL Server spatial data types or spatial data in SQL Azure. You can also pull in Esri shapefiles, KML data, GeoJSON data. These are very common spatial formats that you'll find data available in from both publicly available sources and other sources. So it makes it super easy to overlay that in your application. It's also got code to help you easily bring in services and data from the Bing Maps platform, such as the geocoding services, points of interest, et cetera. And there's a wealth of resources, or utilities, I should say, for things such as taking a couple of points on the globe and determining the as the crow flies distance, the bearing between them, taking complex polygons and reducing them with vertex reduction so you can optimize your performance of your mapping-based applications, and lots more great resources. And there's also code to allow you to do that heat mapping that we were talking about earlier. I'll just super quickly show that actual application in action here. Okay. So this is the example that comes with the actual code download. Shows you how you can choose a sample data size. It'll dynamically create a random set of data. You know, if you're using heat mapping in a kind of a BI or decision-making kind of context, your data won't look as random as this. You'll probably have trends that you'll see in the data that'll be meaningful for you. But you can see that the tool that he's written here allows you to tweak the intensity, the radius that's applied to each of these hotspots or locations that contribute to the hotspots, the heat gradient that you use to actually present the data, and more. So it's a great resource for applications where you want to be showcasing trends in the data. Now I wanted to shift gears and just talk about a couple of new things that have come out that you can take advantage of. These are things that were released prior to the conference, but that are fairly new. The first one is storing geometries in spatial data services. So I mentioned the fact that you can create your own data source and host your own data there. And up until recently, you could host basically addresses or latitudes and longitudes. We've now augmented that so you can upload polylines, polygons, and complex geometries into these data sources in the cloud within Bing Maps. And then in addition to that, you can also query them spatially. So let's say, for example, you've got your point data in the cloud. You want to allow your user to search for your data that you're maintaining in your Bing Maps data source using, let's say, complex polygons. They can draw those polygons on a map potentially. You can do a spatial query, pull out all of your results that sit within that area, and then overlay them. You can do the inverse as well. This is great for if you want to do geofencing, so identifying when someone is actually in a particular area. Let's say not necessarily just a point and radius, but maybe a complex polygon as well. You can load those polygons into the data source, take the user's location or an address that they pass in, and then do that intersection to see which polygon that user sits within. And that's great for kind of trade area allocation applications as well. This is an interesting tool I also wanted to make mention of. This is a little bit different from the other resources we've been talking about, but this is a developer tool called the Bing Code Search Add-in for C#. And this allows you to do something that I know a lot of developers do on a regular basis, which is to go out to the internet and search for code snippets that you want to use to accomplish a particular task within your application. So this, you can download this, it's available in the Visual Studio Gallery today. If you install that, basically what it allows you to do is it's triggered through IntelliSense, and you can actually type your query directly in this instance, you can see the developers wanting to read that file line by line. So they just simply type that in. That query will get sent back to Bing. Bing will basically take the query terms as well as contextual information about the application and pull back code snippets that they can review directly within the IDE and then have it pasted directly into the code. So it's an interesting developer tool that takes advantage of the power of Bing there. So check that out if you're interested. So we're getting near the end of the session, and we're just about ready to wrap here. But before we do, I wanted to do a recap of what we've covered here. We've taken a lap around the various different APIs that are available. We've gone into their core functionality, taken a look at a few sample applications, and dived into the code. Those are all of those ones that we've been taking a look at. You can get access to. What I'd encourage you to do is have a think about the applications, the Windows Store apps that you're developing, how the tools that we've been talking about today can potentially be applied to create engaging and intuitive experiences for your application's end users. And I'd also encourage you to download the deck once it's posted, and you can get access to links to all the resources that we've covered. Yeah, I'd encourage you to get developing with these tools that we've got. I wanted to end off with this slide here. This is, it gives you insight into how you can actually get access to, provision, authenticate, get potentially support for, and the terms associated with each of these APIs and tools that we've been talking about today. So with that, I wanted to ask everyone to please fill out your evaluations. We want to get your feedback so we can improve sessions over time. And I also wanted to thank everybody for coming to the session today. I hope you enjoyed the session. I also hope you enjoyed the Build conference. And I know we're just about out of time here, but I'm going to be sticking around. If anybody has any questions that they want to connect with me on, I'll be sticking around. You can, and we can have a chat. I've also made my contact alias available here. If you want to send me any questions as a follow-up, geinnes@microsoft.com. So with that, I'm going to wrap the session. We're out of time here, but as I said, I'm going to be sticking around if you want to approach me and we can have a chat. So thanks to everybody for coming to this session, and I hope you enjoyed Build.